Hi everyone, and welcome again to our next video on our Chapter 2 Chemistry unit. Before we start, I want to remind you of the flow chart that I showed you in the last video that you should keep in mind as we're studying about how to classify matter. Notice matter is up here and it can be broken down into two different groups, or two different, two different types of matter. We know that matter can be pure, pure, which is not mixed with anything else. It has a definite composition, and those are things that we can write chemical formulas for, such as elements and compounds. And now we're going to talk a little bit about what happens when matter is not pure. And most of the matter you see around you are mixtures. So mixtures have we're going to talk specifically about all of this stuff. So let's just go ahead and jump right into it. So you've got mixtures. Well, mixtures are just that. They are mixtures. They are a combination of two or more substances, and they're not chemically combined, so they're just physically combined. And that's going to have some consequences. Because each of the individual substances in the mixture are not chemically combined with each other, they do retain their own properties. So in other words, in this mixture here, we've got, peas and lima beans and white beans and kidney beans, lots of beans. And each one of those beans retains its own flavor, its own shape, its own melting point, its own boiling point. So those properties are not lost when substances physically combined. The parts of a mixture, remember, are simply mixed together physically and therefore can usually be separated. We can use the individual properties of the components of the mixture to separate them out. So if one component in the mixture, say, has a lower boiling point than another component in the mixture, then we can use the boiling point to separate those two substances from each other. Another thing we can do, an example of how a mixture is simply mixed together, would be oil and water. Oil and water is a really good example of a mixture. Now, mixtures are distinguished from elements and compounds, and this is a real important part for you to get. An element or compound has one set of properties, such as an element such as iron has a certain specific heat, has a certain melting point, has a certain boiling point, has a certain density. Compounds, such as water, will also have its own set of properties, such as the specific heat of water, the boiling point of water, the freezing point of water. And however, in a mixture, when you have all of those different substances physically combined, each element and compound in the mixture retains those really unique properties. And that's how we can separate a mixture into its constituents or parts. The composition of a compound is fixed, which means the composition of an iron bar is going to be just iron atoms. The composition of water is going to be fixed. Remember, you're always going to have two hydrogens for every one oxygen. But the composition of a mixture can vary. So I want you to think of, a salad. You can have different components of the mixture in different proportions throughout the mixture. So we can say the composition of a mixture can vary. Mixtures may look like they're unified, or they may look like they're made up of different substances. And we give those fancy names. For mixtures that appear to be uniform or made up of just one thing, the same throughout, we use the term homogeneous to represent a mixture that appears to be uniform in composition. Or we can say the mixture is heterogeneous, and that means that the mixture looks as though it's made up of more than one substance. Okay, so there's your definition for homogeneous. Now, some people say homogeneous as well. I don't know. Ask Ms. Colfer how to pronounce it. Okay, so heterogeneous, a mixture that has parts with different composition. It's not uniform throughout the mixture. So the best thing to do when you're looking at a mixture is just that. Look at it. And if it looks the same throughout, it's a homogeneous mixture. If it looks like it's a mixture with different parts, it's heterogeneous. Okay, next we have methods of separating mixtures into their individual components. Remember what we're going to rely on about mixtures? That's right, we're going to rely on the individual properties of the constituents to separate them out. So there's 5 different ways that we can do this. One is called filtration, another is called centrifuge, or you can use a centrifuge, another is evaporation, then we have paper chromatography, which you're going to do in the lab coming up, and finally a method of separating mixtures known as decanting. So we're going to look at these real quick individually. So when you look at filtration, filtration is something you do all the time. If you make coffee, if you make tea, you are passing a mixture through a porous device such as filter paper, a tea bag, your coffee filter to separate one component from another. And you're really relying on the different sizes of the particles in the mixture. Because remember, you've got more than one pure substance, so you've got your particle sizes that represent those pure substances that are mixed together are going to be different. You can take advantage of that when you're trying to separate out the components of a mixture. In your body, you have a special organ that's really designed to filter your blood, and that's your kidney. Okay, the next way we can separate out components of a mixture is through evaporation. And evaporation, a good example of that is you're allowing it's salt water. So you're allowing the water to stand, and the water will eventually evaporate and leave behind the crystals of a salt. So evaporation is a really good method to use when you know you have one substance that's dissolved in another substance, such as water. And water has a pretty, water characteristically will evaporate spontaneously, even at room temperature. So if we let that happen, we'll get the solid components of the mixture left behind. Here we have the process of separating a mixture out based on if the solid particles of the liquid mixture settle to the bottom of the container. The liquid can be carefully poured off. That's a fancy word, just decanting. So if someone said, because we're going to do a lab too where you separate out a mixture, and if I look at you and say something like, well, just decant that off, I'm telling you to pour off the liquid at the top from the solid on the bottom. And you're really relying on the physical property of density here, because the solid particles being more dense than the liquid will sink to the bottom. Another method which is pretty cool is using a centrifuge, and the centrifuge will spin around really, really quickly, and that causes the solids to settle down to the bottom of the container. If that doesn't happen, naturally on its own, and you want to speed up that process, you want to put your sample in a centrifuge and just spin that around. It will help you to, and then maybe you want to decant afterwards. A lot of times we use centrifuges in biology when we want to we have a mixture that's composed of cells, and all of the components of a cell have different properties. They're mixtures. So sometimes the components that make up a cell might be lipids, proteins, carbohydrates, nucleic acids. So what happens is we put them in, we spin them around, and we notice that, say the lipid portion of the sample will float to the top, and we'll know what we have in there. So different cell parts have different densities that we can take advantage of through centrifugation. Okay, so here we have paper chromatography, which is another way of physically separating out a mixture. And that's when you're going to use this for dyes or pigments. And we see it a lot too. I think you'll do this in biology next year. You'll use chlorophyll, which is the pigment found in leaves, and you will separate out that chlorophyll to see what other dyes or I'm sorry, what other pigments are in the leaf besides chlorophyll. So that's a pretty cool lab that you're going to do. What you're going to do, I think today or tomorrow, is separate out black ink to see what other dyes make up that ink. And it's really based on the fact that different substances will be soluble in the solvent, which is going to be the liquid that you have in the tube. Certain things are going to stay in the solvent longer, and therefore they're going to run up the paper a further distance from where they started. And you'll take a look at that in the lab. Okay, so here are some questions and practice problems for you. Classify each of the following as a homogeneous mixture or a heterogeneous mixture. So pause the video and you can do that. Okay, so here are your answers. Okay, so hopefully, you did well with that. A soft drink is a Homogeneous mixture, letter C. It looks the same, but don't forget that soft drinks have a lot of different stuff in it, from sugar to high fructose corn syrup to water to carbonic acid, lots of stuff. So it's really, does the matter look different? Does it look like it's composed of one or two different substances? Okay, so what you're going to do now, since you've gone through the vocabulary, you've been introduced to some jargon about matter, let's see what you can do with it. Let's take a look at the Matterstation Lab. You'll notice that before you start the lab, there's several definitions that you need to write. It would be great if you can put these the definitions in your own words. So it's cool if you want to go grab a textbook, but would be even better is if you put your own spin on it. There's 10 stations for you to complete, and each station has a series of questions that are associated with it. If you're at a station and you need some help, Ms. Colfer's in the room. Certainly she can help you with any of this. Please do not taste or directly handle the matter at each station. So especially the station with the Lucky Charms and the Ready Whip. That's right, I'm talking to you. Don't eat the Ready Whip. Okay. Station 9. I need you to wear goggles at Station 9 because you're going to be using isopropyl alcohol to prepare a chromatogram. When you're done with the chromatogram, you're going to tape that paper right on the square, and you'll see this in the lab when you're done. So you've got, I think, probably about 2 days to complete 10 stations. And again, Ms. Kofer's in the room. Ask her questions if you're stuck on any of, any of the stations. So I hope that was helpful. I look forward to seeing you guys when I get back. And okay, so enjoy.